everyone. Last but not least, and that's because of this. If you're going to dinner, make sure you have this with you. That's what I've been told. All right. So just see. So EPEC journey with PLEXOS and how we've sort of been helping with energy transition using PLEXOS and the tools we've built around that. A bit of background about EPEC. So EPEC Group, EPEC's been established around 6-7 years ago, sort of an engineering contractor type business. A lot of grid connection, power system studies, EPC type work, substation design, constructions, and commissioning of the projects. Basically end-to-end services from concept to completion. That's basically sort of the EPEC business. We have around 30 plus grid connection in the NEM in different states, 10 substations that we are sort of building currently in the NEM. Some of the biggest substations we've built in the NEM, 400-500 megawatt solar farm, stubble, and several commissioning. Sort of commissioning is one of our strengths. Record-breaking wind farm commissioning in the WEM, less than 2 months. But like everyone else, we've had many challenges. One of the challenges we've had, or we have in the NEM, is not every project is a good project. That's kind of a business case for EPEC to develop market modeling, help with sort of help our developers come up with the good sides. So that's where we've developed our grid services, which is the focus of this talk. The other one is in the grid connections, in the studies, PSSE, PSCAD studies, they are all sort of tools, studies. When we go to the commissioning, there are a lot of challenges typically. So it's money and time. EPEC's develop hardware in a loop, basically bringing power plant controller in the lab, doing the test, commissioning tests, saving thousands, hundred thousands of dollars. That's one of the, we don't typically sort of seem to be happy with issues, but like our hardware in a loop, like whenever they find issues, they are very happy because they are solving a problem. They're solving a real sort of world problem. Focusing on grid services, grid to revenue investment decision, or in short, grid services is our market modeling, basically, services at EPEC. Why sort of grid services? Typically in the concept phase where sort of we are in early stage, we have land options, or we want to select greenfield sites in the NEM. There are a few approaches available. Before we establish our grid services, we as an engineering sort of consultant or firm and other sort of engineering firms, we typically look at a few network snapshots, which we get from AMO, some high sort of load snapshots, and we run our load flow contingency analysis to understand the congestion and sort of risk of network limitations. There are a lot of issues around that, which you'll sort of see in the next slides, issues around missing resolution, issues around not only missing resolution, but also misleading sort of information, which we want to make our decisions on. Issues around backward looking, not forward looking. So I'll have some slides around that as well. That's kind of the engineering side. The other end is the market modeling and economist type sort of modelers, where they are great at economics, but they suck at sort of power system. So they sort of use a simple model, don't consider network sort of resolutions, simplify the network, and come up with sort of modeling for developers $300 sort of capture price for a battery. That's great. Let's go develop that. But then when you ask them, where did you put sort of battery? Where did you model battery? Did you model constraints? They said it's basically a battery at Sydney. Yeah, of course you get high prices there. This is the challenge we see in the sort of market, causing slow progress, lost sort of revenue, lost opportunities, and lost monies. Let's look at one example on the power system side. I've got this sort of table looking at a few snapshots, network snapshots that you could get from AMO if you are a registered participant in the NEM. Looking at this and basing our decision on a few snapshots, typically seasonal snapshots. The issue is that, as I said, missing resolution. We're only looking at 8 snapshots, right? And if you look at the table, if you look at the top row, there are sort of bunch of core units in different, and columns are the seasonal sort of snapshots. A bunch of core units, bunch of them online, offline. So there's no clear sort of consistent pattern for a base water unit in all of these. Like if you look at base water, for example, there's no clear sort of pattern here. If you go further down, like Coolangatta gas, one of the sort of critical gas in Sydney or Newcastle, and Upper Tumut sort of hydro, it's only running during autumn and summer and a bit sort of during winter sort of seasons. It's not running in other snapshots. Is that like really the case? Like, do we only run like sort of these gas and hydros during autumn high demand? And if it's autumn high, is that like all autumn high sort of periods that we want to look at? If you go further down, like renewables, solar, wind, all over the place. Max generation, min generation, zero, halfway through, etc. So that's where we are missing resolution. And as I said, it could be misleading. Even if we base our decisions on all of these network sort of snapshots as a power system sort of engineer, and come up with 500 megawatt solar farm or battery somewhere in North Queensland or South New South Wales, it could be misleading. But then we could sort of go and look at historical data. We could actually get all of the snapshots from AMO, half-hourly snapshots from AMO, like if you're happy to pay for that. Or we get SCADA data from AMO. The issue with that is that we are not in the past. We are sort of in the future. Our decisions are based on a rapid sort of NEM change. So these two charts I've got from AMO ISP, they are too ambitious in my view, but we are in this sort of rapid transition. If we base our decision on like this world, which is like very steady, sort of linear, it could be misleading for this world, which is a rapid transition. Same for the, not only generation, same for transmission. If we look at AMO historical sort of data or historical NEM data, this is the network we're going to have in the next 10, 20 years. Like these are ISP sort of actionable future augmentations. If we use the existing networks sort of data and come up with congestion, is that going to sort of be the same when we have Project Energy Connect, HumeLink, Western Renewable Link, VNI West, etc. So that's why sort of we've developed our grid services, and we've been sort of lucky. It's Matt here. So around 2 years ago, I reached out to Matt. So we got one PLEXOS license, start building our model. We had a lot of support from Energy Xcelerate, understand how PLEXOS works, LT, SD, MT, PASA, etc. Oops, sorry. Around early 2024, we started sort of PLEXOS. Then, for being an engineering sort of firm, we developed tools around PLEXOS and PSSE. which I've been told is sort of kind of, to some extent, unique. We have integrated PLEXOS and PSSC, two sort of well-known power system and market modeling tools, and develop a marginal loss factor in the NEM. We actually design and develop AMO MLF engine in the same year. So they're using our engine for the MLF publications. We managed to create sort of a model around PLEXOS and PSSC to create every single constraints in the NEM now and in the future after any upgrades that you can think of. So that sort of made us to work with a lot of developers, do a lot of congestion, curtailment assessment, not only on system normal, but also post-outages. We are able to formulate constraints post-outages, which is very critical for batteries. Like a lot of battery developers come to us and say, I don't sort of care about system normal constraints. When I care about congestion and curtailment for my batteries when we have outages, which we typically see high prices, $20,000 sort of dollars prices, a significant lost revenue for my battery, as opposed to renewables that you generate or lose. Batteries are sort of business case are typically around like volatile prices. And then since then we've been sort of providing our services to our clients, and we've developed our grid headroom sort of assessment tool, which is I'll show you a few examples here. How our headroom assessment tool works. It's designed as a first step sort of model as a cost-effective approach, PLEXOS PSSC integration, time and cost-effective. Whether you have a bunch of land options you want to select sort of your sites, or you have projects that you don't want to spend a lot of time and money, you just want to understand the major risks around the network. Starting with assumptions, all about the assumptions, which we agree with sort of client on assumptions, feeding all the inputs, demand, generators, transmission, upgrades, etc. in our PLEXOS model. We run our PLEXOS, typically look at sort of near future or sort of in 2030s, LTS, MT, PASA, SD, all the way. We get the dispatch. And from here, we feed half-hourly dispatch to PSSC, run AC load flow, not DC load flow. So we don't simplify that in PSSC either. So AC load flow, like for a year, it's 17,520 sort of load flow, which we get half-hourly line flows for every single lines and transformers in the NEM. We've developed some tools, sort of secret sauce here, that gives us ability to look at every single contingencies sort of in the NEM. Yeah, so grid headroom assessment, half-hourly resolution, not only a few snapshots, forward-looking, not backward, historical data. So visualize sort of on a portal, simulate real-world scenarios, any scenarios you want to model, and understand the impact of load flow across different time of the day, which I'll show you. And deep, sort of dive deep, you could select sort of any line on this map, look at the line flows, etc., etc. Let's look at some examples. First, big picture. Again, PLEXOS, or the PLEXOS modeling, feed to PSSC, and just visualize here through our tool. Looking at two snapshots, 30% headroom available on 220 kV and high voltage transmission lines in New South Wales. On the left, it's not too bad, but that's kind of a big picture. Sorry. A big picture is like some constraints around Sydney sort of area, N-0 still. So we don't operate the NEM on N-0, it's on N-1. And if 30% headroom for a 330 kV line is around 300 sort of megawatt, if you call. And if I go with 50% headroom, a bit of stress test, yeah, line 39, sort of the line, important line, which we'll see in sort of next few months, some news around that. It's getting red, and a bunch of other lines in New South Wales close to interconnector in QNI, all the way south, all sort of yellowish, sort of not much headroom available. That's the sort of different headroom. Let's look at 2 time steps. Midday, if you look at midday, bunch of solars, like in Queensland especially, and northern New South Wales, feeding down to Sydney. All the lines sort of yellow, same kind of around south New South Wales. But if you go to sort of evening peak period time, I think it's 6:30 sort of time, south New South Wales is kind of crashing. Northern New South Wales is feeling better because like Queensland needs some sort of generation stay there. Just 2 snapshots for different time periods. Yeah, question I get. I have multiple sort of land options. Tell me sort of how much capacity I can afford without spending weeks and months of simulations and like hundreds of thousands of dollars. Let's look at one example. Let's look at Tamworth in northern New South Wales, a location which we've done our modeling, half-hourly PLEXOS simulation, half-hourly PSSC line load flow and line flows, and built in sort of analytics in the tool that I showed you. Look at the hosting capacity. Only if I learn this. Look at injecting at Tamworth, looking at the N-1 first layer, all the sort of line connected to Tamworth, and second layer, sort of downstream constraints. Different technologies, solar, wind, 2-hour, I should add 8-hour here, data center sort of things for different layers. If I'm too strict with my curtailment, no curtailment allowed, no hosting capacity at Tamworth. So, but I'm not a developer, so developers typically take some risks. And that's my sort of main constraints. Brook to Tamworth for the trip of Lido to Tamworth is the contingency I have. The timestamp, but I can go and select sort of different curtailment that I'm happy with. Sort of, that's my risk appetite. 5% is good enough. Then I can afford 200 megawatts-ish solar there, and different sort of 500, is that 500 megawatt? 500 megawatt battery with different storage size at Tamworth. But this is just number, like maybe 10 years ago, like developers were just after a number. Give me my sort of numbers, I'll plug in my financial model, done. But these days, developers are more knowledgeable, try to understand more. From there, we look at the same line and look at the flow on this line. Blue line is N-0. Red line is N-1 for this line, Brook to Tamworth, for the trip of Lido to Tamworth. Flow is typically sort of negative. That means it's coming down from Queensland during the day, lowest in the midnight and evening. That's the time of day average flow I'll look at. And if I look at the flow duration curve, basically 17,520 load flow line flows, sort of sorted from largest to smallest. Yeah, so what I saw in the previous slide, that no hosting capacity is available, I see it here as well. No host, so basically I'm hitting the limit on either direction, but it's just like less than 5% of the time. If I'm developing a solar, 5% is not a big deal curtailment for me. Just looking at the time. Yeah, still have time. But let's sort of go and add some generation at Tamworth. For example, in this case, I had 4-hour battery, 400 megawatt, and basically a hybrid project, and 4-hour and 400 megawatt solar farm. And my line flow is updated now, so it's kind of pretty much flat during the day and evening because I still charge during the day and discharge in the evening, and my solar is sort of generating. But what I see in the duration curve, now I'm sort of exceeding the line limits. But again, it's around 5% of the time. Some curtailment, depending on my risk appetite, I might be happy with that or not. From here, so coming up with the capacity that sort of is reasonable, then we plug into a long-term forecast, look at the 20, 25 years, and look at the curtailment for my project. This is a sort of curtailment modeling for a battery, looking at the battery. Looking at the battery, obviously sort of curtailment, a lot of curtailment during super peak sort of period, if we call, losing a lot of money and revenue. We can still sort of discharge in the later evening or like early morning, but we're not sort of gaining or we're losing money. This is a few snapshot here, 28, 29, 2030 sort of years, like as we have some upgrades, sort of the curtailment goes down. But this is system normal. We have developed some tools around PLEXOS that we can model constraints post outages. For example, this case shows us line 8 sort of outage and a constraint that doesn't bind pre-outage or in a system normal, but as soon as we put line 8, this constraint starts binding in the model, which is, as I said, is a critical modeling for batteries. Typically, one of the drivers of NEM volatility or high prices is like network outages. So we get a lot of question, can we sort of look at outages and how they impact our revenue? I think that's it. Just don't forget your badge for the dinner.
We do have time for questions, so.
Thanks, Nadali, for the presentation. Interested to know how the interaction works with developers when they come to you with a project. Is your role to simply look at what they've asked you to do and then provide those insights back, or do you try to look at ways with them around what could be more economically efficient, relieving congestion, better placement of their resources or assets or different technologies to still kind of serve the same purpose?
Yeah, I think a bit of both. So like working with developers, sort of currently working with one of the developers, they want to identify, like they've sold a bunch of assets and they want to identify the next round of the pipeline, like 10, 15 sites across the NEM, right? So I can only look at the network that sort of, they will have to overlay all the other sort of things, land, et cetera, et cetera. But from the network perspective, I will be able to give them, okay, these are sort of good sort of locations. That's one thing. But we've developed some other tools sort of around PLEXOS that so a lot of existing solar farms, they want to add a battery, 2-hour, 4-hour. Like the question is that, do we do a DC coupled, AC coupled? Sort of that's kind of where we use our power system expertise and what we call single asset optimization to understand the kind of most economic sort of configuration for them, whether a 400 megawatt battery and solar hybrid DC coupled is the best option. Do they have to consider AC coupled with system strength sort of remediation and other things? But yeah, some clients come to us, they already have a project or like sort of in mind, we sort of, for the financial close or transaction, sort of, they ask us to do modeling, typical market modeling forecast.